Right, so now we're going to do some area and circumference examples like you'll see in Alex. So circumference is equal to pi times diameter, or you can write it as 2 pi times radius. And then area is equal to pi times radius squared. Right, so suppose you're given a circle with a diameter of 28 centimeters. We can go ahead and we can use the circumference formula directly, but if we wanted to use the area formula, we need to find the radius. So we're going to go ahead and find the radius before we start this problem. So we know that the relationship between the diameter and the radius is that the diameter is twice the radius. So we would let 28 be substituted for the diameter, make that equal to 2r and solve for r, and we get that r is 14 centimeters. So now to find the circumference, if you choose to use the times diameter formula, that's fine. In this case, we know that the diameter is 28 centimeters, and so we would write this as 28 pi centimeters. All right, so these instructions told us to our answers as an exact value, which means we want to leave pi as part of our answer. And so I should have left a space. Because pi goes on forever in terms of the decimals, and the minute you stop writing down a decimal, it's no longer exact. So you just want to leave 28 pi when they ask for an exact answer. If you had chosen to use circumference equals 2 pi r, still pretty much the same. You would substitute 14 centimeters in for r, and you still get 28 pi centimeters. All right, when we go to my area, that formula is pi r squared. All right, so we need to make sure we're going to substitute 14 centimeters in for r, it's squared. And so this time, when you square 14, that's 196. The pi doesn't squared, but then those centimeters also get squared. In addition to the 14. So area units are in square centimeters. Circumference is in linear units. Because the circumference is just the perimeter of a circle. If you think about putting a piece of string around the edge of a circle and then straightening it out and then measuring that along a ruler, that's what the circumference would be. And those are linear units. Some of the problems, Alex, are going to ask you to use 3.14 for pi. So you would proceed on those problems just the same way we had done when we were doing the exact value. But here we had that circumference was 28 pi. So Alex is going to ask you to use 3.14 for pi. And then when you type that in on your calculator, you get 87.92. And the units are still centimeters. And then area, you would plug into the area formula, whatever they gave you. So we know that's 196 pi problem that we were given. And then instead of leaving our answer with pi this time, we're going to multiply it by, 3.14. And when we take 26 and multiply by 3.14, we get 615.44. And because this is area, it's square centimeters. Now, Alex is also going to give you guys some concentric circle problems. And so I found a picture of the target sign. And it has, let's suppose that it has a diameter of 24 inches and each ring has a width of 12 inches. All right, so what that means is that the diameter of this interior circle here, the bullseye, has a radius of 12, okay? And then each ring here has the width of 12. Okay. And if an 8-ounce bottle of paint covers 2,304 square inches, how many 8-ounce bottles of paint do we need to buy to repaint the sign? And they ask you to use 3.14 for the value of sign, of pi rather. Okay, so now there are two things going on. One of them is I need to find the bullseye, but I also need to find the area of this outer ring. And so then the area of the outer ring is going to equal the area of the biggest circle minus the area of that medium-sized circle. Okay, so we're looking for a difference between the areas of two concentric circles. So we need to figure out, well, what is the radius of the big circle? Well, we know that each here has a width of 12. And so then that means that the radius of the big circle would be 12 plus 12 plus 12, that small circle plus that middle ring plus the outer ring. And so then that'd be 36. And the radius of that medium circle would be this inner bullseye radius plus 12. So that would be 24. So now if I want to find the area of the circle minus the area of the medium circle, I'm going to do pi times 36 squared minus the area of the medium circle, which would be pi times 24 squared. So that ends up being 1,296 pi minus 576 pi, which is 720 pi. And then if I plug in 3.14 for pi, that gives me 2,260.8, and that's square inches. So that's how much paint, but the area of the outer ring is going to be. And then we also need to find the area of the bullseye, which is that small circle. So that's going to be pi times its radius, which is 12 squared. So that's 144 pi. And when we plug in 3.14 for pi, we find out that the area of the bullseye is 452.16 square inches. All right, so then what's the total area that we're going to be painting? Well, we're going to be painting 2,206.8. And then we're going to add on the bullseye, which is 452.16. And that gives us 2,712.96. All right. So the number of bottles that I'm going to need, well, if each one does 2304, if I divide, that tells me that I need 1.1775 bottles. The question is actually not exactly how much paint we're going to need. It's how many bottles do we need to buy. So that means since I need more than one bottle, I need to buy 2. Right. So this problem is actually a little bit harder than one that you're going to see on Alex because it's got this inner bullseye. I think the ones on Alex only show kind of the outer ring calculation. But this is a process you would go through. And so let me know if you have any questions.